solving exponential and logarithmic equations. We're going to start with exponentials. Okay. One way you can solve exponential equations is called by equating exponents, meaning you get the same base, then you can just set the exponents equal to each other. So I'm looking here, I've got 81 and I've got 1/3. Well, I know that 81 is 3 to the 4th and 1/3 is 3 to the negative first power. Okay? Since I know I can put them, I can have the same base, that's what we're going to do. So this is 3 to the 4th power, that's 81, and then to the 3 minus x power. So that's going to equal 3 to the negative first power to the 5x minus 6. Okay. Now, using the power to a power property, we multiply the exponents. So this is 3. 4 times 3 is 12. 4 times negative x is negative 4x equals 3. Negative 1 times 5x is negative 5x. Negative 1 times negative 6 is positive 6. Now I have the same base, different exponents, but they're equal to each other. So therefore the exponents must be equal to each other. So we just drop the 3's, and it's 12 minus 4x equals negative 5x plus 6. Add the 5x, subtract the 12. And that's going to leave us with x equals negative 6. And you should always check your answers. I'm going to trust that you do on this one. Okay. Next, what if we cannot equate the bases? What if we can't make the bases equal each other? We got 7 to the 9x power equals 15. Well, if you can't make the bases equal each other, the only way to get an x out of the exponent position is by using the properties of logarithms. Remember the power property? Remember I said it was one of my favorites? This is why. Because we can get the exponent out, or the variable out of the exponent position. So that's what we're going to do. And the first step in that process is to take the log of both sides. It's kind of like another operation. So we're going to log both sides. And then with the log, the power property, we can bring that 9x and make it an exponent. Or, I misspoke, a coefficient. 9x times the log of 7 equals the log of 15. Okay? Now the log of 7, that's a common log, that's just a number. Okay? Treat it as such. Don't get all wrapped up in what is that number. Just remember, it is a number. And we can divide by numbers, so that's what we're going to do. We've got 9 times x times the log of 7. Divide by 9 log 7 on both sides. 9 log 7. And x will equal the log of 15 divided by 9 log 7. And notice I've put it in parentheses. The reason I've done that is to help you remember that you have to put that in parentheses when you use your calculator. Because at this point, you just take the log of 15 and you divide it by 9 times the log of 7. So x equals 0.155. Okay. Now over here, in this case, I don't have e to the negative 0.3x by itself. I've got some other stuff happening to it. So before we can take the log of both sides, we have to get the thing with the exponent with the x in it by itself. So let's add 7 to both sides. That's going to be 4e to the negative 0.3x equals 20. Divide by 4, gives us e to the negative 0.3x equals 5. And at this point, I'm going to take the log of both sides. But what log am I going to use? What log would make sense? This is an e. The natural log would make sense. So that's the one we're going to do. Take the natural log of both sides. When we do that, that means we can bring this exponent to the coefficient position. So negative 0.3x times the natural log of e equals the natural log of 5. Well, what is the natural log of e? What exponent do I take e to get e? It's 1. The natural log of e is 1. So essentially I've got negative 0.3x times 1 equals the natural log of 5. That's convenient. So now all we have to do is divide by negative 0.3. And we've got x. So x equals the natural log of 5 divided by the negative 0.3. And you grab your calculator and you do that. Natural log of 5 divided by a negative 0.3. Negative 5.36. Now remember, when we're dealing with logs and we get a crazy decimal, don't just round it to the whole number or the tenth. Take it out a couple. I'm using 3, using 2. Some of them will tell you to go to the 10,000ths or the thousandths, So use a few decimals. Alright, logarithmic equations. Logarithms, like exponentials, sometimes you can, as long as your log and the base is the same, you can just set those arguments equal to each other. So I've got the natural log of this equals the natural log of that. So this better equal that. So that's what we do. 7x minus 4 equals 2x plus 11. And we solve. Subtract the 2x, add the 4. 5x equals 15, x equals 3. And of course you should check your answers. This one will let it kind of go, but it does work. I did check my answer before the video. Okay. What if they're not taking a log of both sides? What if this, like we've got here, log base 2 of x minus 6 equals 5? In this case, we need to get the x out of this logarithm, and the only way to do that is to switch to exponential form. So that means 2 to the 5th power equals that. Okay? So that's what we're going to do. 2 to the 5th power equals x minus 6. So that's 32 equals x minus 6. Add 6 to both sides, x equals 38. And you can check your answers quickly if we plug that in. 38 minus 6 is 32. 2 to the 5th does indeed equal 32. What if we have an expanded logarithm? Okay, here's one that's got an x here and an x here, and it equals 2. What do we do here? Well, before you can do anything with switching to exponential form, you have to have it written as one log, a single log. So we have to condense it. So, let's see, this is a log plus a log. Well, that tells me, that plus sign tells me it's the product property. So what that means is that this is going to be the log of 5x times x minus 1 equals 2. Now we have it written as a single log, and I'm going to do things in 2 steps because I'm limited on space here. I'm going to distribute and switch it to exponential form at the same time. So log, if the log doesn't have a little number written here, it's a common log, which means it is base 10. So that means 10 to the second power equals 5x squared minus 5x. Okay. Oh, I have an x squared. That's a quadratic. That tells me I better set everything equal to 0 to solve. So let's square that, move it over. So we've got 100 equals 5x squared minus 5x. Move it over. 0 equals 5x squared minus 5x minus 100. Now, I don't want to factor that because I see 5, 5, and 100. I can divide all of this by 5. That's going to give me 0 equals x squared minus x minus 20. That looks much nicer to factor to me. 0 equals x minus 5, x plus 4. Okay, remember, factors of 20, that'll subtract to 1, negative 5, and positive 4. So x equals 5 and x equals negative 4. This is where it's extremely important to check your answers. So when we check, let's check the 5 first, just because I did that one first. So the log of 5 times 5, that's 25, plus the log of 4. Does that indeed equal 2? Use your calculator. Common logs, use your calculator. Check, it does, so 5 is definitely an answer. Now let's see if negative 4. Negative 4 times 5 is negative 20, plus the log of negative 4 minus 1 is negative 5. Does that equal 2? Well, think about it. If I'm taking the log of something, it's got to give me an exponent. Is there an exponent of 10? Is there a power of 10 that'll give me a negative answer? Okay. Is there a power of 10 that'll give me a negative answer? Can I take 10 to any power and get a negative answer? Oh, some of you would say 10 to the negative 2 is negative 100. But I think you're out of your mind. So, no. The fact is, this is not real, so it is not a solution. If you put that into your calculator, it'll tell you an error. Okay? So, this is what's called an extraneous solution. We get those sometimes with logarithms. Next one. Here's another one where we've got to condense it. This time it's base 4. Pay attention to that. Okay, so log base 4 of x times x plus 12 equals 3. Okay, convert to exponential form and distribute. 4 to the third power equals x squared plus 12x. 64 equals x squared plus 12x. It's an x squared, which tells me I have to set it equal to 0. So x squared plus 12x minus 64 equals 0. Factor. What are the factors of 64 that'll subtract to 12? Well, 4 and 16. Since 16 is greater, 16 gets the plus, the 4 gets the minus. This is x, this is x. So x equals negative 16 and x equals 4. Now, check your answers. If we plug in, okay, if we plug in negative 16, we're going to get the log of 4 equals negative 4. That's another one where we can never get it. So guess what? Negative 16 is not a solution. Does that mean I don't need to check 4? No, you still need to check 4. So let's try it. The log base 4 of 4 plus 12, does that equal, or plus the log base 4 of 4, does that equal 3? Well, log base 4 of 16 plus the log base 4 of 4. Okay, well 16, 4 to the second power is 16, so that's 2. 4 to the first power is 4, so that's 1. check, it does work.